Hello everyone. In this series, we are going to learn about the basics of Spring Framework. We are going to understand the concepts like dependency injection, inversion of control, application context, and many more concepts that you can see right on your screen. This is not going to be theoretical only. We are going to build one headless file sharing application from scratch and learn that how we can implement all the concepts that we have gone through in this series. So without wasting any time, let's get started. Alright, let us try to understand that why this new keyword is a problematic thing when we talk about big enterprise level applications. Consider this project. So in this project, we have one payment service which is dependent on this payment provider, right? And this payment service interface is having one implementation and this payment provider is having two different implementations. Right now, we just need to understand that this payment service is dependent on this payment provider. Okay. So this is the project and we have this main method. It is a pretty simple main method. You can see that we are simply creating one object of payment provider. Then we are creating the payment service and finally we are using the payment service to execute the payment. Let me also run this application. Right, so like this we will get the output. So you see that this project is working fine. There is no such issue with this new keyword. Let's try to understand that when this new keyword will become a problem. Right, so this is a dependency graph of this one service. Okay, so I have created different levels. You can see that level 1, level 2, and we have up to level n. Right, so this is how the dependency graph of this service class is, and I'm calling the dependencies that are present at this level 1 as the direct dependencies. Okay, because they are directly related to this service class, and the dependencies that are present from this level 2 to level n, I'm calling them as the indirect dependencies because they are not directly related to this service class. Okay, the dependencies that are present at level 1, they can also have their own set of dependencies. They can also have their own set of dependencies. It is not like that they cannot have their own set of dependencies. It is not restricted, but definitely they can have their own set of dependencies, and that is where we are getting this level 2. That means the dependencies of level 1 classes are present at level 2, and similarly we are going to have the level 3, level 4, and up to level n. Right, now we need to understand that what is going to be the correct order in order to resolve all the dependencies and finally create the object of the service class. Okay, so we have to start from the very last level and we have to move towards the very first level. Okay, that is the correct order. Then only we will be able to create the class of, then only we will be able to create the object of this service class, right? Currently, we are having just one service and one dependency in our project. Now, suppose this dependency list grows to, let's say, more than 100. We are having now more than 100 dependency for just one service, right? And we are manually managing the dependencies. We have to create the object of those classes and we have to provide those dependencies, right? That we have to do. And now, after we understood this particular graph, we know that we need to have the correct order of resolving the dependency. Then only we can resolve all the dependencies and finally create the object of the service class, right? That we have understood. So we are manually creating the object with the help of new keyword, right? So that is a repetitive task. We are just using the new keyword to create the object. And second thing that we have to keep in mind that we are we are going to need the correct order. We are going to need the correct order. Then only we will be able to resolve all the dependencies, right? So you see, this is kind of a manual burden on us, and we are not doing any task which is actually going to improve our application, right? And wasting our lots of time. So you see that if if we can somehow remove this manual burden, we can automate this process of creating the object and managing those objects, then we can utilize that particular time in improving our application. So this is where this Spring framework comes into the frame. So Spring framework is going to automate this process. Spring framework is going to automate this process of creating and managing object for us, right? So Spring framework is going to create and manage Java class object for us, and it is going to reduce the boilerplate code, which is nothing but the repetitive code. Okay. Now this Spring framework is dependent on two things, that are inversion of control and dependency injection. You can say these are the building blocks of this Spring framework. Right. Let us understand IoC, that is inversion of control, and dependency injection. Okay. Now that we have given the control, we have transferred the control from us, or we can say from developer to Spring framework. You see that we have inverted the control. Now Spring framework is going to create the object for us. So this inverting of control is known as the inversion of control, right? So we have inverted the control. When we were manually creating the objects, then we were responsible for providing the dependency, right? Now that we have given the control to Spring framework, it is creating and managing object for us. So now it is the responsibility of Spring framework to provide these dependencies wherever they are required, and that is known as the dependency injection. We are going to discuss these two terms later on in this series. Right now, in short, if we try to understand these two terms, so we can understand like this. Okay. All right, let us see how we can generate a Spring Boot project before we move any further and learn about Spring framework working. So we have to head over to this star.spring.io. This is the website, and using this website, you can generate any Spring Boot project, right? So this is the Spring Initializer website. So you will get interface like this, right? On the left hand side, we have to provide the details of our project, and on the right hand side, we have the dependency section. So let us start with the left hand side. So over here, first we have to select the build tool, right? So you can select between Gradle and Maven. I have selected Maven. Then we have the choices between the programming languages. So it totally depends on you which language you want to use. So I'm going with the Java. Then we need to select the Spring Boot version. So I have selected this latest stable version, that is the 4.0.3. Now what is this Spring Boot, that we are going to understand later in this series. For now, just select the latest stable version. Right, so now how to fill this project metadata. First we have the group. Now if you have any domain, then you can use it over here, or you can leave it as it is. Then we have the artifact. So write the name of your project over here. Okay, then we have the description. So you can give the description of your project over here. And if you want to customize the package name, then you can customize it. Otherwise, you can also leave it as it is. Then we have the packaging. Okay, so we have two packaging, jar and WAR. Right now, when we create the web application, when we create the REST client using this REST API, using this Spring Boot, so we can have two different choices, right? Let's say we want to use the server that is being provided with this Spring Boot only, embedded server, so we can go with this jar file packaging. And if we want to deploy it on some other server, then we can go with this WAR packaging, right? So it depends what you want to do. Then we have the configuration. Again, we have the two choices. You can select either one of them. So I'm going with the properties, and then we have the Java version, which Java version you want to use. So I'm going with the latest one, that is the 25, Java version 25. So now what are dependencies? So in the last video, we have seen that we were having the class and it was dependent on some other classes, right? So like this, we have our project, we want to create our project, but we are dependent on some external library. So these external libraries are nothing but the dependencies. So you will find so many dependencies over here. we are going to explore some of them because it is a huge library. We cannot explore each and every dependency over here, right? So for now, I'm not selecting any of the dependencies because we just want to focus on the Spring framework. So we are not adding any dependencies, right? Now we just have to click on this generate and this will download the project. Now what we have to do is we have to simply unzip this project, unzip this file and open it in our favorite IDE. That's it. That's all we need to do. Right, so this is how we generate the Spring Boot project. All right, now we know that Spring Framework automates the creation and management of Java class objects. Let us understand how Spring Framework find Java classes, create objects, and manage those objects. We will understand 5 different things. First, we will understand what is component scanning, then bean identification. After that, what is application context, then dependency injection, and finally beans lifecycle. Now, before moving further, let me discuss one of the important term for this whole series, that is the Spring Bean. Now, Spring Bean is nothing but a Java class object only that is being managed by Spring Framework. So this is Spring Bean, or you can simply call it Bean. Right. We have a Spring Framework and the project classes, right? Now let's understand that how Spring Framework is going to find out these classes. Right. For a moment, just forget about the Spring Framework. Just suppose you are at the newly joined office. So this is your office. It is a big office. It is having many floors, floor 1, 2, and up to n floor. Now what you have to do over here is you have to find your department. You have to figure out your department. Now unluckily, you don't have any kind of help over here. There is no reception desk. There is no one to help you. You don't have any kind of help. Okay. So what you are going to do? You will say, okay, I will start my search from this very first floor, that is the floor 1, right? And you will try to find your department. Once this floor 1 is finished, then you will go to this floor 2 and you will find your department over here. And similarly, you will explore, you will go to other floors till you find your department, right? This is what you are going to do. Now, we see that if someone would have just told you that your department is at, let's say, this floor 2, so you would have directly gone there and start your search from here, right? But now, as you don't have any kind of help, so this whole process is what? It is time consuming and exhaustive as well, right? So this whole process is exhaustive and time consuming. Now let's take this other scenario, right? So now this time we are having one map, or you can see the direction in which it is written that the department that you are trying to find out is present at the floor 2. Okay, so you will start your search from here because now you know that you don't have to search for all the other floors except this floor 2. Okay, so you will start your search from here and you will find your department, right? So now this whole process is very less time consuming and as well as very less exhaustive, right? So this map or this direction given you one anchor point, which is what? This flow to, that you have to start from this flow to. So this is what your anchor point. Now keep this example in your mind and try to map it with the Spring framework. Now in Spring framework, we have one concept of anchor point, which is nothing but this Spring Boot application annotation, right? So it will indicate, it will tell Spring framework that this is going to be your start point and the scanning will start from there and the scanning will start from there, right? See over here in this project, we have this Spring Boot application annotation and it is present on this application class. Okay, this application class is marked with this Spring Boot application annotation, right? And this application class is present in this package. this com.example.spring framework basics. Okay, so this package is going to become the base package. This package is going to become the base package. That means that the scanning will start from here. That means the scanning will start from here, and it will scan all the packages that are present inside this package. Okay, so we have model, we have provider, service. So these all packages will be scanned, right? Now let me run the application and let me show you that the component classes that are present in this package are scanned. Okay, so let me run this. Let me just turn on the debugging mode so that we can easily see the scanning. Right, so this time we are getting so many logs, right? Let me search for this payment provider class, right? So this is what we want. You see that there is this scanner, and this scanner identify the component class, which is what? This mock payment provider and the payment service IMPL class. So you can see that how Spring Framework scans the project classes, right? So it needs one base package, and that base package is uh, identified by this annotation. Okay, so by default, it will scan the it will start the scanning from this base package only. And suppose if I create one component class inside this, let me create one class, right? So we have another class inside this Spring REST package, and you will see that these Spring Framework basics and this Spring REST, they both are at the same level, but this application class is present inside this Spring Framework basics, so that will become the base package and not this. So this will be ignored by default. So let me again run the application and let me show you. You see that this class is not present. Okay, that means it is not being scanned by default, right? So if this Spring Boot application annotation is present in this com.example.p1 package, so it is going to scan the packages that are present inside this, like this controller and service, but it is not going to scan this p2 package, which is at the same level with this p1, right? Okay, so this is the important concept. Remember this concept. So by default, this is the behavior of scanning. All right, now we know that how Spring Framework scans the project classes with the help of this anchor point, and also how we can specify custom packages that we want Spring Framework to scan, right? So that we have seen how it is going to identify classes that it needs to manage, right? So there is one annotation, that is the add component annotation, and with the help of this annotation only it get to know that yes, this is the class that it needs to manage, right? Now, if I open this payment service IMPL class, then you will see that it is marked with this add component, that is specifying, that is telling Spring Framework that you need to manage this particular class, and similarly for this mock payment provider. Okay, and you will see that this bits payment provider is not having annotation, is not having any annotation. So when I will run this application, then you will see that Spring Framework is actually not identifying this as the component class which it needs to manage. So let me search this, that is the bits payment. You see there is no such class, but if I search for mock payment, then we are getting this mock payment provider, right? So then we are getting this log that this class is identified as the component class, right? So this is how Spring Framework identifies the classes that it needs to manage, right? Now let me just list out all the objects that are being created, or you can say that the beans that are being created by this Spring Framework. Right now, don't worry about that how I am doing this. Just try to understand the point that I'm trying to explain, right? Right, so this is a list of all the beans that are being created by Spring Framework. And you see that this mock payment provider and this payment service IMPL, bean of both the classes are created. Right, now the thing is, now we know that Spring Framework is creating the object of these component classes, but still we are not able to access it. And now we have to figure out that how we can access these objects and use them inside our project. Right, now we know that Spring Framework is creating objects of the component classes, but still we don't know how to access them. Now let us figure out that how we can access these objects and use them inside our project. We need to understand about this application context. So this application context is created before even the scanning of the project classes starts. Okay, so Spring Framework scans the classes and there is one bean registry and registers them inside this registry. You can think of it like a map. Okay, so this application context is having the information that how to get these beans. So there is one Spring IoC container where all these beans are present, and application context know how to get those beans. And how we can get the beans, there are two different methods. First one is the by bean name. We can give the bean name and we can get the object. Other method is the by class type. We can give the class type and then we will get the bean. Right, now you see that this is the main method of this application, and we are running this spring application dot run method. Okay, so inside this method you see that this we are creating this no, we are this Spring Framework is creating this application context. So this application context is being created first. Okay, then the beans are registered. So let me run this application. Right, so you will see that first this application context is created, and then you see that uh, there is one hash map, concurrent hash map, and inside this information of beans are registered. Okay, so you see that all the beans are getting registered over here. Right, so this is how Spring Framework starts. It creates the application context, then the scanning starts, and all the beans are being registered into bean registry. Okay, right, now let's see how this get bean method works. Okay, so we have discussed about the two different methods. So first I'm discussing with this class type method. So here I'm passing the class type, right, and you will see that it is going to return the bean of this particular class. Okay, right, so you see that we got the bean of this payment service IMPL because this is the actual implementation. Okay, and if I resume this application, then you will see that this application is working fine, and you can see our output over here. Right, so this is how we can get the beans that are created by Spring Framework. Now let's see another method. So another method is also pretty simple. All we need to do is we need to give the name of the bean. Okay, so we want payment service IMPL. Now you might think that how we will get this name. So by default what Spring follows is that basically it is going to convert, suppose this is our class, so it is going to convert this into camel casing, right, and this is the by default name. Okay, so we can provide the default name over here, and one extra step we have to do, and that is we have to typecast it because this method returns the object type. Right, so we have to typecast it, and now if I run this application, you'll see that everything is working fine. Okay, so we are getting our output. This is how we can get the bean with the help of this application context. So this application context is very important component. All right, let us try to understand the difference between the tight coupling and loose coupling, and why do we want our application to be loosely coupled rather than tightly coupled. Let's understand this point. Consider this example. On the left hand side, you can see that there is a laptop which is having the soldered RAM. That means the RAM is glued with the motherboard, right? Now, if we try to change this RAM, then there is a risk of damaging the laptop's motherboard as well as the RAM. So this kind of setup is known as the tightly coupled setup. On the other hand, we are having the laptop which is having the RAM slot. Now this RAM slot is having some specification. That means we can use whatever RAM we want. We just have to keep one thing in mind, that the RAM that we are going to use, it must follow these specifications. That's it. We can simply put the RAM in the slot and we can use the RAM. Right, so you can see how easy it is to change the RAM and simply use that. Okay, right, so keep this example in your mind, and we are going to see the difference between tightly coupled and loosely coupled setup in the code. Then we will understand it in a better way. Right, so this is the project, and if I open this payment service class, then you will see that there is a no interface of payment service, and you will also not find the interface of this payment provider. I'm directly using the implementation of payment provider, so we have two implementation, right? Okay, so I have removed the interfaces that we are seeing from the starting. Okay, now I see that this object is being created over here and it is used in this method, right? And this mock payment provider is having the method that is the process payment. Okay, now suppose if I want to use this bits payment provider, so what I'm going to do, I'm going to simply change the uh, object over here, right? So let's change it, right? And I need to change the type over here, right? So this is done. Now you see that after changing this provider, we are getting one more error. That is, this payment provider is not having this kind of method. This method is not present in this bits payment provider. So what happened right now is that accidentally this existing functionality is broken. The existing functionality of this project is broken because there was no common shared contract between this payment provider, and we were following the tightly coupled system. So you can see this kind of problem we face when we use the tightly coupled system. Changing the implementation is not that easy part with tight coupling setup. Right, now again introduce the interfaces that we are seeing from the starting. Okay, so you see that now if I try to change the implementation of this payment provider, okay, so what I'm going to do is I'm going to simply use the bits payment provider. You see that there is no error, and if I run this application again, it's going to run perfectly fine. So there is no issue in that, right? So how we have created this slot, so we have used the interface, and that interface is actually acting like the slot. Okay, so this payment service is dependent on this payment provider, which is the interface. You can understand it like a contract. So it is a contract, so this payment service is dependent on this contract. So as long as we are providing the correct implementation, correct class which is following this contract, we can use that class over here. So we have changed the tightly coupled system to loosely coupled system. Now I see that changing the component is pretty simple, and this is where we get the dependencies, right? And you see that earlier we were creating the object inside this class only, and now we have inverted the control. We have given the control to this main method, and when we are using the Spring framework, then we are giving that control to Spring framework, right? So this is the inversion of control. right? So this was important to make you understand that why this inversion of control and dependency injection was there right from the start. Okay, so this is why we are using these concepts and from where we get this concept of dependency list. All right, in this quick session, we are going to understand that how Spring Framework actually creates and manages object for us. And not only Spring Framework, but this reflection API that we are going to understand is the backbone of many tools and plugins that we use regularly. Now, suppose there is one guy, so he's a researcher on this wireless signals, right? So he was thinking that if somehow he got the powers, he got some kind of superpowers, like he can see all the waves around him, all the wireless signals around him, and even can access those signals and can change their properties like frequency, amplitude, or phase. Like this superpower, we have the Java Reflection API, using which we can change the behavior of objects at the runtime. We can access their fields, we can access their methods, and we can change and we can even change the values. Let us quickly go through some of the classes that we need to know before diving into hands-on of this reflection API. So this reflection API is in this java.lang.reflect package, right? And we need to know about few classes. Now, first one is the class. Yes, this is a class named class only. So it represents the runtime class of the object. Then we have the constructor. So it represents the constructor, right? Then we have the field. So it represents the field. And finally, we have the methods, right? So it represents the methods of the object. Right, so we have one class that is wireless signal, and you can see that we have properties like amplitude, frequency, phase, and all of these properties are private. And we only have the getter, there are no setter for these properties, right? And if I run this application, so over here, what we are doing is we are simply printing out the values, signal values at uh, some interval, okay? Let me copy this and save this. And why I'm saving this, you will get to know in a moment. Right, now let's do one thing. Let's change the value of amplitude from 1 to 2 after some time period. Okay, so let's do one thing. Let's change the value of this amplitude after 0.04. Okay, now we don't have any setter property, so we are going to use the Java Reflection API. Now, first thing we need to understand that we need to have the access of class type. Now, how we are going to access it? So there are two different methods. First one is using the object. So we can use the object name, then we can use this method dot get class, right? So this is one method. Another method is using the class name only. So we are going to use the class name and dot class. So this will also return the class type, that is the reflection package. Okay, now we can access the methods that are present in this class. We can access the fields, we can access the constructors, and we can access even more metadata like annotations, uh, modifiers, module name, and there are lots of properties that we can access, right? But for now we are just going to understand a basic. We are not going to deep dive into this topic. We are just going to learn that much so that we can understand that how things are going behind the scene, the Spring framework that we are currently learning. Now we want to change the amplitude, right? So for that we need to get access to the fields. Now, how we can access? We are going to use simply the get declared field method, right? And we have to pass the field name. So field name is the amplitude. So let me write it over here. Right, so this will return the amplitude field and we have to save it one variable. Let me create variable. Okay, so this will also throw one exception, that is the no such field exception. So if the field that we are, if the name that we are passing is not present, this reflection API is not able to find that field, then it will throw this exception. So we can simply do one thing, we can simply add throws exception over here, right? So we'll not get any exception handling related message. Why we are saving this into one variable? Because every time when we access this field, we use this get declared field or get declared method, right? So we get the copy of that field or method. So that's why we need to save it in one variable. Now we are going to make it accessible. And why we are making it accessible? Because this is a private property, right? So we have to make it accessible, otherwise we cannot access it. Now we are going to simply set the value. Okay, we need to pass two things. First one is the object. So object is Wi-Fi signal and the value that we want to set. So let's make it 2, right? Now let me run this. You can see this program is working fine. There is no issue. And let me again copy this whole output and save it in one file. Right, so we have both the output. Let me do one thing. Let me compare this output 1 with 2. Okay, right, so you can see that after the time period of 0.04, you can see the change in values. You can see the change in values. That means we have changed the amplitude, right? So it is interesting, right? Now let's try to do one thing. Now let's try to access this private method also. So this calculate instantaneous phase method, we are going to access it. And this method is used to get the value at given time. So we are not going to use this particular method. We are going to use this method and we are going to calculate the value, right? So in this main method only. Let me comment out this. Now we need to calculate the value. For that, first we need to get the method, that private method. Again, we need the class, okay? And then we are going to use get declared method. Now for field, it was simple. We just have to pass the name. But for method, we have to pass two things. First, the name. So that we can copy from here. And next that we have to pass is the list of arguments. Now, how we can pass that? So you see that what exactly we need to pass is the class type, right? So again, how to get the class type? So we know this is accepting this double. So we are going to use this double dot class, and this is how we can access the class type. Okay. So you might be having question that what if we were not having the access of this class, we were not able to see that this method is accepting what kind of argument, right? So how we will find the argument type? So for that you can do what? You can access all the methods, right? We have one method that is get declared methods, right? So this will return you the array of all the methods. Then you can filter out this method. You will get the method object and then you can find out the return type. Okay, so that is another method, right? So let me save it in one variable. We are going to use this method, but before using it we are going to set accessible is equal to true because this is private, right? Now we want to use this method. So how we can use this? So basically we want to invoke this method. Again, this invoke will accept two arguments, first the object and then the arguments. Now we have to pass the argument, so argument is going to be this t, right? Now this returns the object type, so we have to typecast it. Okay, and we have to add the amplitude, so we can get the amplitude because we are having this getter method. Okay. Okay, a small mistake, we have to use the multiplication over here. Now let me again run this application, and now let me save it into this output 3. Right, so you can see that we are getting the same output. Output 2 is same as the output 3. right? So you can see that we are able to access the private method also. So this is how the Spring framework behind the scene works. It get access to our classes and create objects and also manages those objects like this. All right, let us get back to Spring framework. Let us try to understand that what are different methods that Spring framework provides for resolving dependencies. Now, if you see this payment service IMPL class, then we have one dependency that is of this payment provider, right? Now, how this Spring framework is providing this dependency, that we need to understand. For a moment, just forget about this Spring framework. Let's try to figure out that how we can resolve this dependency without even this Spring framework. Okay, suppose we have one class, and in that class we are having constructor with the dependency list. And what we can do is we can simply use that constructor, right? We can simply use that constructor, and we can provide the dependency at the time of creating that object, right? Now if we don't have that constructor, then what we are going to do, and what option we are left with, then we will check if there is any setter method for that dependency or not. So if there is setter method, then we are going to use that setter method to set the dependency. Once we will create the object, and after that we are going to set the dependency, right? Now, is there any other option that we are left with? Yes, there is one method, and that is the Java reflection API that we have discussed in the previous section. Okay, so we have figured out all the three dependency styles that are provided with this Spring framework, right? So first one is the constructor injection. So this is going to use the constructor. Then we have the setter injection. This is going to use the setter method. And third one is the field injection. This is going to use this Java reflection API to set the value of the dependency, right? So uh, we have three different dependency injection styles. Now, till now you might have noticed that to specify anything to Spring framework, we are using annotations, right? Now for this also we have one annotation, and that is auto wired annotation. Let's see how to use this annotation and how to specify Spring framework which type of dependency injection style to use. We are going to start with the constructor dependency injection. Right now we are using the constructor dependency injection only, but we are not using this auto wired annotation. Why? Because there is only one constructor in this class, right? So there is no need of that annotation. Now if we have more than one constructor, let me create one more constructor and also set this value of payment provider. Now if I run this application, let me run this. Right, so you can see that we are getting one exception, and it is saying that cannot invoke this process because this payment provider is null. Right now, by default, if we provide this default constructor, so default behavior of Spring framework is to select this constructor only, and if we want some other constructor to be used for creating the object, then we need to specify. Okay, so how we are going to specify? We are going to use this auto add annotation. Now this constructor will be used to create the object of this class. Let me again run this application. Right, so this time you see that there is no error, and we are able to see the output. So that's how we use this constructor dependency injection. Now let me remove all these constructors, and let us understand how the setter dependency injection style works. Right now, we are going to create one setter for this field. Okay, and we are going to mark this setter with auto wired annotation. Why? Because we are specifying that this method is going to be used for resolving the dependency, that is the payment provider. Right, so let me run this application. Okay, so you can see that we are getting the output, right? So this is how the setter injection is going to work. Now let's see this field injection. Okay, now we are going to mark this field with this auto wide annotation, right? And now let me run this application, and you will see this time also it is working perfectly fine. There is no issue, there is no such issue. So this is how this field injection works, right? So we have discussed all the three different dependency injection styles. Now which one is recommended? So the constructor dependency injection style is recommended because when we use the constructor dependency injection, uh, we know that what all dependencies that are required by this particular class in order to create the object. That is actually helpful. Suppose if we are using this particular class in testing, then we know that what all dependencies we need to provide. Or suppose if we are using using the service in some another project, we are importing this module in some other project and we are using this particular class, then how would we know that what all dependencies that are required? So if we are using that constructor dependency, then we know that these are the dependencies that we need to provide in order to create the object. So that's why this constructor dependency injection is always preferred. Then we have the setter injection. So this setter injection is recommended when you have dependency which is optional, right? Which is not mandatory. So you can go with this setter injection. Again, with this field injection, we'll not be able to see that what all dependencies are required. So it might seem cleaner, but it is not recommended. And it is also using, it is forcing to use this reflection API. So it is not recommended. Right, so this is how this Spring framework resolves all the dependencies. All right, so this Spring framework is doing great work by automating this creation of objects and managing these objects, right? But what if we want to have some control on this creation and destruction of Spring Beans or the objects? So let's try to understand this point, that how we can have some control over this automation process. First, let us understand that why we need to have some control, right? Suppose we have the application, right? And this application connects to one database. Okay. Now, this connection is having maximum connection limit of 3. And suppose we are running 3 instances of this application, then there will be 3 connection open with this database, right? Now, suppose if you want to restart any one of this application instance, right? Now, the service which is connecting to this database, there is no such mechanism that when the service is destroyed, so it disconnect the connection, it closes the connection with this database. There is no such mechanism. Now what will happen, suppose if this application restarts, so connection is in the open state, right? And we have already connected, we have already used the maximum limit. When this application will restart and try to reconnect to this database again, then there will be an error because the maximum connection limit is already reached, right? So we need some control. For this, we need to understand about the beans life cycle, right? So first, the bean is scanned, the class is actually scanned, and after that, it is instantiated. Okay, so after that, the object of that class is created, right? Then the dependency injection is performed. After that, there is the initialization phase. So still this bean is not ready. There is this initialization phase, and we can control this phase with this at post construct annotation, right? After this, the bean is ready, so it can be used in our application, right? So you can say this in use phase is the longest phase of this beans life cycle, because this is active till the application is closed. Now there is also a way to execute some logic just before destroying this bean. So we can control that thing with this annotation, that is the pre-destroy annotation, right? So this is how the beans life cycle looks like. So first we have the instantiation phase, then dependency injection happens, then we have the initialization, then the in use, and finally the destruction phase, right? So this is the payment service class. Okay, now I've added one method, that is the init method, and mark this method with post construct. Why? Because this is going to initialize, this is going to run just after the dependency injection is, right? And then this bean will be utilized. Okay, and when this bean is about to destroy, then this particular method will be called. So this method is marked with pre-destroy annotation, right? So let me run this application. Okay, now let's check the logs and we will find the trace over here. Now see, this payment service IMPL class is identified as the component class. Okay, then you see that the instance of this payment service IMPL is created, right? And after that, you will see that auto wiring by type from bean name is basically the dependency injection is being done over here, right? And after the dependency injection, this init method is called of this payment service IMPL, and you can see that we will be getting this message over here, right? Then this payment service is in the phase where it is being utilized, right? So you see that we are getting this output. So we are actually using this payment service. Okay, finally you will see that this bean is getting destroyed, right? So you can see that this bean is getting destroyed, and now just before this bean is actually destroyed, this method that we have marked with pre-destroy is called, right? So this is how we can have the control. So this will not lead to a condition that we have discussed right now, right? So that's why this bean life cycle is important to understand. Now, what if we have two beans of the same type? Then how Spring Framework is going to decide that which one to select and which one to reject? So this is what we are going to understand now. You see that we are having two implementation of this payment provider. But till now, I was not using this bits pro payment provider as the component. Now let me also mark as the component and let me run the application. Right, so you see that we get one exception, that is no unique bean definition exception. Okay, and if we read the message, then you can see that it is written over here that no qualifying bean of type payment provider. Okay, so there are two beans present, but this Spring Framework is not able to decide that which bean to select, right? And also we are getting uh, one hint that consider marking one of the bean as primary, or we can use this qualifier to identify which bean we have to use, right? So let's understand this solution that is provided in this log only. Now we have two different ways to tell Spring Framework how to resolve this ambiguity. First one is using the primary annotation. Now we can make either one of them as the default implementation. Now that's where we are going to use the primary annotation. Now we are going to use one another annotation, that is the primary, right? So I'm making this mock payment provider as the default one. Now if I run this application, now you will see that we are not getting any kind of error and this application is working fine because we have provided the default implementation that is going to be used if there are multiple implementation present, right? So this is one way to resolve the ambiguity. Now let's see the another way. Now we are not going to use this primary annotation. We are going to tell that which bean we want to use. Okay, so in this payment provider, in this payment service, we are injecting this payment provider, right? So over here we are going to tell that which bean we want to use. So we need another annotation, and that is the qualifier annotation. Now we have to provide the name of the bean over here. So we know that what is the default naming convention that Spring Framework follows, right? So we can simply write the name over here. So let's say I want to use this bits payment provider over here, right? So I have to give the name of this bean, right? So this is going to be the name of bean, and let me run this application, right? You see that this time this bits payment provider is used. We can also give the custom name to our beans. What we have to do is just come to this component annotation, and we can give the custom name. Okay, so let me give a name like default payment provider, right? So now we can use this name also. Let me copy this and paste it over here. Now we'll see that when I run this application, and you will see that again we are using this mock payment provider. So this is how we have two different ways to resolve the ambiguity in Spring Framework. All right, let us understand that how to use external library classes in our project and how Spring Framework is going to manage these classes. Because when we use external libraries, we don't have access to their source code. So we cannot add this component annotation to those classes. Let me show you. You see, this is a external class, right? And I want to use this class. Now, if I try to add the annotation, you see that the message is coming, file is read only. We cannot change the code over here because it's not the source code. It is the compiled code that we are getting, that we are able to see. So now this is what we are going to understand, that how we are going to manage this situation. We are going to create one configuration class. Okay, so let me name it app config, and we will mark this class with configuration annotation. Till now everything was automated, right? So every component class was picked up by this Spring Framework automatically, and object was created and even destroyed when the work is over. But now we need to provide some manual configuration for these external classes, external library classes, and then we will hand over these classes to Spring Framework, right? So this is what this configuration file is going to do. Again, you can think of this configuration is nothing but a component only. Okay, you see that over here this component is used. Okay, so it is, you can think of it as a configuration only. Now how we are going to create the object or a bean of external classes? So we need to create one method, right? Let's say we want to use this currency converter, right? So we are going to create one method which is going to return this currency converter instance. And now over here we have to manually create the instance of this currency converter, and we have to return that. Okay, so now you see that this currency converter required this exchange rate provider, so we need to provide this dependency. Okay, so one way is that we can simply create the object of this over here, like new exchange rate provider, and over here we need to provide two things, API URL and API key. So we will keep these two properties as blank, right? Okay, and we are going to provide this over here, right? And one more thing, that we have to mark this method with at bean, so that Spring Framework is notified that this object or this bean is also to be managed by the Spring Framework, right? Now let's do one thing, let's add this to our payment service, right? So we have added this into the dependency list. Okay, and now you will see that this currency converter will also be injected by this Spring framework. Let's add one logic that is going to use currency converter. Okay, so let's simply convert the amount into some other currency. Okay, so what we are going to do is we are going to convert this INR into USD. Okay, right, so this is how we have used the currency converter. And now let me run this code. So you can see now this INR is converted into US dollar. Okay, so this is how you see we are using this external class. Over here you can see that this class is also provided by this Spring framework only, right? Now one more thing that we can do over here is instead of creating this object of this new this exchange rate provider over here, we can create the bean of this also, so that if it is required somewhere else we can also inject that, right? So we can create one more method, exchange rate provider, and then we have to simply return the instance of this. Right, now how we are going to use it in this currency converter method, we are going to simply mention the argument, right? That's all we have to do. Okay, and it will be automatically injected by this Spring framework, right? So let me run this application. You see that the code is working perfectly fine. There is no issue in the code. So this is how we can create the object of external classes, and we can give the control to Spring framework. So we just have to create the object only, and rest everything will be taken care by this Spring framework. All right, I have added the API URL and API key to this exchange rate provider, and inside this application class, inside this main method, I have made a small change that now I am reading this argument array and passing the values as the payment amount, and then using that value to make the payment object and finally executing the payment. So this is a small change in this main method. Now this time we are going to run this application in a different way. We are going to build the package of this project, and then we are going to run that package. Now how we can build the package? So we are going to use the Maven build tool. Open the terminal, right? And there is a command that is mvn package. Okay, and this will generate the jar file of this project. So this is the output path, right? And it is inside this project only, project folder only. You have to go to this target folder and you will find this jar file. So this is the file that is generated by this command. Now we are going to run this jar file. Again, open the terminal and use the command java-jar, and now we need the path of this jar package. Right click on this, copy path slash reference, and copy this path, right, and paste it over here and simply hit run. You see that the application executed, right, but we have not passed any amount, so no payment was executed. Now this time let me pass some amounts. Okay, so I am passing 5 different amounts. Let me hit enter and execute this. First we have transaction number 00, it is processed, then 01, it is also processed, then 02, it is also processed, and 03 is also processed, right? You see that we are getting one error for the last payment, that you have reached the maximum limit of free API key, right? So this API key that we are using over here is the free one. So let me do what? Let me change this API key. So let me change it with this. Okay, right now you see that this change was actually not related to any business logic. This was just a configuration change, right? And for just a small configuration change, what we are doing is we are opening the source code, we are changing the value, and then what we have to do is we have to again build the project like this, and then we have to run the project, right? But actually these many steps are not required. There is a better way to provide the configuration. There is a better way to provide the configuration, and that is what we are going to learn now. So there is one file in the resources folder, that is the application.properties file. Here we can define some properties that we can utilize inside our application. Now there are some predefined properties, and also we can create our own properties that we want to utilize inside our application, right? Now first let me open the page where we will find all the common properties. So this is the URL. I will post the URL in the description section. Okay, here you will find all the common application properties attributes, and it is written over here that where to use these properties and also their default value, right? Now we are not going to use those common attributes, common properties. We are going to create our custom properties. Okay, we are going to use those properties. Suppose we have to create the property for this exchange rate provider, right? Now for this API key, now what we are going to do is we are going to create one group, that is the currency group, and then there is API dot key. Okay, like this we have created one property, and over here we can provide the value. Now we are going to copy this value and paste it over here. Now how we are going to use this value inside our application, let's understand that. Okay, we want that this value to be injected over here. What we can do is we can create one variable like private string API key. Okay, then we can mark this variable with value annotation, and here we have to provide the name of the property that we want to inject. Okay, and format is like this. We have to use a dollar sign and then curly braces, and inside this we have to provide the name of the property. So I will just copy this and paste it over here. Right, now we can replace this with this variable, and we can do this for this API URL also. So let me create another property, and this time it is going to be currency.api.url. Now let me also write the URL. Okay, and also copy this. Let me create another variable. Again we are going to mark this variable with this value annotation, right? And we can replace the API URL also with this variable. Okay, now we are going to run this application. Okay, so this time we are going to run it normally with this IDE only, right? So you can see that the application is running perfectly fine. Okay, this is not the recommended way to inject the values. You can compare it with like the field injection. Okay, so we don't prefer that field injection, right? So what we can do instead, we are going to create one constructor, right? And we are going to inject these value over here, and if you want you can make them final also. Now why this is recommended, suppose you want to test this file, you want to write one unit test. Okay, and now you have to create the object of this class. Okay, in the previous approach there was no way to pass these API key and API URL. we have to forcefully use the reflection API, and that is not recommended. Now with this constructor, when we are creating the object of this class, we can simply pass the values over here only. So that is why this approach is recommended. Okay, now let me run this application again. Right, you see there is no problem in the application. So this is a recommended way. Now in this application.properties file, currently we are not in the microservice architecture, so there is no other service where we can fetch this configuration. So right now also, if we want to change the API key, then we have to change the value over here and we have to rebuild the application. Okay, but if we want to solve that problem, what we can do is we can use the environment variable. Okay, so we are going to pass the value with the environment variable, or you can say the system variables. So the value will be stored in the system and it will be picked from there and used inside our application. Let's see how we can do that. So we are going to need two properties. So let me create two properties. First one is going to be currency API key. Okay, and another one we can create as the currency API URL. Okay, we can copy these value and paste it in the text editor. Right now we are going to need this variable name. Let me copy this, and over here we are going to remove this value and we are going to pass the name of system variable or environment variable that we are going to use. Right, so this is how we provide the name. And in case if this variable is not present, then we need to provide the fallback value. So for that we use colon and then the fallback value. Right, so over here what we can do is we can pass this free API key. Okay, now we are going to do this for URL also. Okay, so this is done. Now how we can pass the environment variables? So we can make change over here also in this application configuration. Right, so we can go to this edit and we can pass the values over here. Right, we can click on this icon and can see that we are getting this user environment variable, and we can create the custom variables. Let me copy paste the values. Right, now click OK, apply, and you can simply run this. You see that it is working perfectly fine. So this is one way, and if you want to pass the values from command line, so let me show you how we can do that. right? So right, so this is the command. First, we are going to pass all the key value of the system variables or the environment variables, right? Then we are going to use the command line, okay, to run this jar file, and this is the list of arguments, okay? So this is another way. There are multiple ways. Simply paste it over here and run the application, right? You can see that it is working fine. Now this is one way that we can inject these value. Now suppose if we want to group these properties, we want to create one group of these properties and then um, inject, or then we want to utilize that group inside our application. So that will be easier to manage. Like we can create one class, and that class is going to have all these fields, and we can simply inject that class and use the values, right? Now that is also possible. Let's see how we can do that. So over here in this config package, we are going to create one class, and that is going to be currency properties, right? Again, we have to use the annotation, and the annotation is going to be configuration properties, right? And we need to provide this prefix, okay? We need to provide the prefix. So this prefix is going to be this one, okay? This part of this property. So whatever prefix that we pass, it is going to be matched against these properties, and wherever that prefix is matched, then those properties will be picked, right? Now how we are going to inject these properties, how we are going to tell a Spring framework that uh, these are the properties that we want, okay? So first we need to specify the prefix. Now here in this properties file, you see that this dot, it is behaving just like the separator of different properties inside the class, right? So you see that we need to create one property, or we need to create one class that is going to be API, right? So we need one more class, okay? So we have the property API, and we are going to create one more class. So this is going to be private. We are going to make it private API. We can make like currency API. Here the name of this class is not a concern, but this variable name should be same as that is in this property, right? So that we have to take care. Otherwise, we have to configure more. The Spring framework will not be able to perform as automation magic, right? So let's create this class also, and we are going to create this inside this class only, okay? Now inside this API, we have two different properties, right? One is the key and another one is the URL. So we are going to create those properties, and both of them are going to be string. Again, the name of the property is the thing that we have to keep in mind. And we need to create the getters and setters as well. Great. So this class is done. Now we have to come back to this configuration file, and over here we have to use one more annotation, and that is the enable configuration properties. And over here we need to provide the properties class, okay? So this is the array, so we are going to this we are going to use this curly braces, and we need to pass this currency props dot class, right? So this much configuration we need, okay? So now let me run this, and okay, so let me first remove this also. Here we want the currency props, okay? This is done. Now we have to make change over here also, right? So let me run this now, right? You can see that it is working perfectly fine. So this is the better way if we want more than one properties. So we can combine them inside one property class, right? And we can simply inject this class wherever we want, and we can utilize the properties value, right? So we have seen two different ways. First one is using the value annotation, and another one is using the configuration properties class. And this is how we externalize the configuration. Now, what's the real benefit? That if we just want to change the configuration, then we don't need to open the source code and change the value. We can directly change the value over here, or in the, if we are using the system variable, then we can simply change the value in the system variable and just hit restart. We just have to restart our application, and new values will be picked up and they will be used inside our application. So that's why we externalize the configuration. Let us quickly see that where these application properties that we are providing, they are available, they are present in this application. Okay, so the execution starts from here, right? So we will open this run method, and now we'll go to this method, and over here you see that this environment is being prepared. So when this is done, all the properties that we write in this application properties file are available. So let me run this, and right, so now if I open this environment variable, and inside if we check the property sources in the sources list, and if we go over here, you see that we have all the properties over here that are present inside this application.properties file. All right. Now suppose instead of requesting for this payment service for just one time, we are requesting Spring Framework to give us this payment service multiple times. Now what you think is Spring Framework going to do? Is it going to provide us the brand new instance every time, or is it going to give us the same instance? Let's try to find out. Right, so we are going to move this inside the for loop. We are going to request every time a new payment service, and then we are going to make the payment, right? Okay, so to track the instance, we are going to create one variable, and that is going to be of type set. We are going to have one set which is going to store the unique address of the instance that we get every time. Okay, right, now we are going to save the unique address, right? And once this for loop is over, we are going to print out two things. First is the transaction count, and next we are going to print out the this instance address set. Right, now let me run this application. Okay, so over here we can see that the transaction count is 5. We made 5 payments. Now if you see this set, here we are having only just one address, right? We are having just one unique address. That means we can say every time when we requested for this payment service, we were getting the same object. We were getting the same object, and that means that by default, the behavior of Spring Framework is to give us the shared instance, the same instance every time when we request. And this is also known as the singleton pattern. Now, what if we want to override this default behavior? So yes, Spring provides the way to override this default behavior. Let's see how. So I've added this payment audit logger. Basically, it is going to simply log every step once the payment is started till the payment process is done for every payment, right? So this is what this payment audit logger is going to do. Now I'm using this inside payment service, right? So you can see that it is logging every step. And let me run this application. So we can see that what kind of output we are getting, right? You see that we are getting the information of the transaction one, okay, from the process, from this payment process started to payment process end. Now, this is the trail of transaction one, but when we see the trail of this transaction two, so you will find that we are getting the information of this transaction two. That's okay, but we are also getting the information of this transaction one, which is not required. So we don't want this kind of behavior, because one transaction should not have the information of other transaction. They should be isolated, right? Now what we can do is we can request for new instance every time when we are using it inside this execute payment method. Okay, now what we have to do is we have to specify the scope. So for that, again, we have the annotation. We are going to use the scope annotation, and let me open this annotation. And you see, we have two type of scope, that are singleton and prototype. So by default, it is singleton. That means the instance will be shared, and other one is the prototype. That means that every time when we request for the instance, a brand new instance will be provided, right? So we need this one. Let me copy this, right? So we have override the default behavior. Now the scope is prototype. Okay, that means now when we use this payment audit logger, that problem that we just saw is going to be resolved, right? So let me run this. Okay, so this is where from, so this is the start of the logs, and you see that, okay, this first log is correct. Then again, the same issue, this problem is not resolved. But as I mentioned that if we use the prototype scope, then we will get the brand new instance every time when we request for it, right? Another thing is that over here, this payment service is the singleton bean or the singleton object, okay? And we are injecting the prototype bean into this singleton bean, okay? That's what we are doing. Now the problem is that whenever this type of situation come, then the new instances is not provided every time, because you see that the instance of this payment service, it will be created once, okay, after that it will be not created. So that's the problem. We will not get the new instance of this payment audit logger every time, and this problem is known as the proxy problem. Now how we are going to solve this? What we are going to do is we are not going to inject this payment audit logger. Instead, we are going to inject the object provider, which is going to provide the object of this particular type, right? So we have one class that is the object provider, and we need to specify what type of object we want. So we want payment audit logger, and we can name it as object provider. We have to also make changes over here, right? So this is done. Now over here, what we are going to do is we are going to use this object provider, and we are going to use the method that is get object, and we are going to save it in one variable, and that is going to be payment audit logger, so that we don't have to change everywhere. Okay, so now we have the payment audit logger, and now we will get the brand new instance of this payment audit logger. Okay, so let me run this now, right? So now you see that we are getting the logs in a correct way. So this is the information of transaction one, then this is the information of transaction two, and there is no mention of this transaction one, right? So we are getting the correct logs this time. So this is how we solve this proxy problem, and this is how we specify Spring framework that we want the brand new instance of this particular class every time when we request for it. All right. In this section, we are going to learn something interesting. We are going to learn about the SpEL. Now, what is this? This is Spring Expression Language, and you can think of it like a mini programming language embedded directly within the Spring framework. It allows you to query, manipulate, evaluate data like Java objects, collections, application properties at runtime rather than writing hard-coded Java logic. Okay, and now if the standard Java is something that builds your application, so this SpEL is a control panel that lets you dynamically change and evaluate how the application behaves while it is actively running. So this is how we can define this SpEL, Spring Expression Language. Now, first of all, let us understand about the important components of this SpEL, and then we will understand that how we can utilize this SpEL inside our Spring Boot projects. So we have four important components. First one is the expression parser, then we have the expression, evaluation context, and lastly we have the root object. Okay, now to understand these four components, let's take one example of simple program, and with the help of that we are going to understand all these components. So this is a simple Java program which is simply filtering out this numbers list. Okay, the first thing that we need to understand is the expression. Now what is expression? Now in this program we want to filter out the numbers, right? Now for filtering out the numbers we have to give certain condition, we have to provide some condition. Okay, now this is the condition that if the current number is greater than threshold, then we need to filter out that number, right? Okay, so this is the expression. Now this expression cannot be evaluated directly. Okay, so this is the source code, so this cannot be executed. We need to convert, this need to be converted into the executable bytecode, and then only this can be executed, right? So this is where the expression parser comes into the frame. It is going to parse the expression, it is going to parse the expression and give the compiled expression object which we can use to evaluate the value. Okay, so this is expression and expression parser. Now next component is the evaluation context. Now for filtering out the numbers, what we need this threshold. This threshold decides that which number is going to be in this filtered numbers list. So we need this threshold, and from where we will get this threshold? So we will get this either from the local variable, we just like this, or we will have some environment where this variable is present. So that is what the evaluation context. So this evaluation context contains all the information, all the necessary variables that are required for evaluating that expression, that compiled expression. What is the root object? Okay, so we understood that we need expression, and that can be passed with expression parser, and it will be evaluated in the evaluation context. Okay, with the help of this evaluation context. To evaluate this expression, what we need something, we need uh, something on which we can perform this operation, we can evaluate this expression, right? So that is what is the root object, or the, you can say, the data source. In this program you can see that this list, in this program you can see that this list of numbers is the data source or the root object, because on this we are performing the operation, right? So these are the four important components of this SpEL. Now keep this example in your mind. Okay, this simple Java program. Now I'm going to show you the SpEL version of this thing. So this is the program using SpEL. So you see that we have the parser, and this is the raw expression. This is the raw expression, and when this raw expression will be passed using this parser, we will get the expression, and that this is the compiled expression. And then we have the context, and you can see that we are setting one variable in the context, that is the threshold, which is required by this expression, right? And finally we have the root object, and over here you can see that it is a simple list. Okay, and finally we are evaluating this expression. We are passing the context, we are giving the root object, and the desired result type. Okay, so we want that the desired result type is going to be this list. Okay, so let me run this. Right, so we are getting the values 15 and 20. Now, how to understand this expression, how to write these expression, that we need to understand. Okay, so for that we need to understand the syntax of this SpEL, and we are not going to use the SpEL like this. There is a better way to use this SpEL, and we are going to use like that. Now let's understand about the syntax. Okay, so basically this SpEL is written like this. This is the pound symbol or the hash symbol, and we have the curly braces, and inside these curly braces we provide the expression. Okay, now this is important thing to note, that we have seen this dollar and curly braces thing, right? We have seen this when we were fetching the values from application or properties. Now this is not SpEL syntax. This is just for fetching the values from application property. So this is a property placeholder. So do not confuse with this thing, right? So this is the important thing to note. Now with the SpEL, we can perform, we can evaluate simple literals, constant values. Okay, we can perform mathematical operations, logical operation, and even we can work with beans and the Java objects. Let's have some hands-on on this basic syntax thing, so that we can understand it in a better way, and then we are going to use it in our Spring Boot project. Okay, now we'll be using it in a different way. Okay, so you see that this is a component class, right? Now that we want that let's say we have one property, private int result. Okay, or let's say math result, and we want that this field to be initialized with some value. And to initialize or to give the value to this field, what we are going to do is we are going to use the SpEL. Now how we are going to use it? So we need this value annotation, and inside this we are going to use the SpEL expression. So first is this pound sign required, then we need the curly braces, and inside this we are going to pass the expression. Let's add 2001 plus 25. Right now, how we are going to see how we are going to see that it is working. So for that we need now how we are going to see that this is working. So for that we are going to have one init method, right? And this is simply a post construct method which will be running once the object is created and the dependency injection is being done. Okay, so here we can simply do what? We can simply print out these things, these variables, right? So you can see that we are getting this math result is equal to 2026. So this is how we can perform the basic arithmetic without, you see, we are not accessing any object or anything. We are simply giving the expression and it is being evaluated. Now if we want simple literals, then that can also be done. Okay, let's create one variable. Okay, and this time I'm going to simply pass the literal, right? And over here we need another print statement to print out the result, right? You can see that we are getting the value over here. Now next let's see that how we can access the object. So we have this channel stats class. Okay, so again you see that this is a component class. Okay, so this is a component class. Now what we are going to do is we are going to access this class at the runtime, and uh, we will assign the values from this class. Okay, let's do this thing. So let's create one variable. Now how we are going to do this? So first we need the name of the bean. So what is the name of this bean? So this is the name, channel stats. Let me copy this, and we are going to use it here. And what we need the subscribers, right? So we will simply write subscribers. Okay, and now let me print this out. Right, you can see that subscribers coming out to be 1050. Let's check that. Okay, you see that the value that is present inside this channel stats class, we are able to access that. Now let's try to perform some logical operation. Okay, and for this we are going to use this is active property of this channel stats. Let's create another variable, and over here what we are going to do is we are going to use this channel status object, and we need this is active property. And if it is active, what we want to return that it is active creator. Okay, you can see that the status that we are getting is the active creator because the channel is active, and if we will make it false, then we will get the status as on brick. And suppose we want to filter out the list of videos based on the views. We want the videos in which the views are greater than 1000. Okay, so we want that list. Now we can also perform that thing. Let's see how we can do that. So let's first create one variable. Now we want to use the function. So it's simple. We can simply write the function name. Let me uh, copy the function name. It is the get videos. To perform the condition or to apply the condition, what we can do is we can simply use the operator, that is the collection selection operator. So we are going to put dot and then question mark, and then inside this square bracket we are going to give the condition. Now inside this square bracket we have the access to this video object, and for this video object what we need to access the views property, right? So we'll be writing views. Okay, and this views must be greater than 1000. That's what we want. Videos in which the views are greater than 1000. Right, so you see that how easy it is to just write down the filter logic over here. So this is how we can use this SpEL. We are not going to dive much into this because this is not the SpEL related video. Right, so this is the full guide of SpEL. Over here you can find different ways to use this SpEL, how you can access properties, how you can manipulate arrays, list, maps, different things. Okay, so you'll find all the information over here, and I will give this list in the description, so you can uh, simply open this and explore whatever you need according to your project. Okay, or do let me know that if you want the full video on this SpEL, so I will be making that video also. All right, we are back to our Spring Basic project, Spring Framework Basics project, and over here how we can use this SpEL. Okay, let's try to do simple thing. We're not going to do much complex thing over here. Let's create one property like app dot currency supported. Okay, and we are going to provide the list of supported currencies. Right, so this is the list of supported currencies, and we can use this inside our payment service. Okay, and how we are going to inject this, let's see that. let's create one variable. So this is going to be list of string supported currencies. And over here, we are going to inject that list and we are going to write the SpEL expression. Now inside this, we want to access the property. So that's why we are using this property placeholder. And the property that we need is this. So we are going to copy this and paste it over here. Now why I'm using this single quotes, because uh, we want the value that we get from here to be treated as the literal. Okay, and we will have the, you can say, the string in which we have the comma separated values, and then what we can do is we can simply convert that list into, we can convert that string into a list of strings. Okay, so we are going to use the split method, and the delimiter is going to be comma, and that's it. That's all we need to do for this expression. And over here we are going to simply assign this to supported currency variable. Okay, and we can add one line over here that before checking the amount only, we can check if payment dot currency or supported currency dot contains this payment dot currency. Okay, now let's do one thing. Let's change the currency over here. We need to add one more line, that is the print summary, otherwise we will not get the output. So let's do this and now run this application, and you can see that this payment is rejected because of invalid currency. List of supported currencies are USD, INR, right? So this is how we can utilize this SpEL. There are a lot of different ways, different places where we can utilize this Spring expression language. So it might need some more hands-on or uh, some more experimenting with this SpEL to get better understanding of this. So do try to use it in different ways in your project, and then you will understand it in a better way. All right. Now, suppose if we want to run our application in different environments like the development, testing, or the production. Okay, so these environments are going to have different configurations. So this development environment is going to have, let's say it is connected to the development database. It is using the development API keys like that. Okay. Then for testing, we will have some other configuration, and for production, that means the application is live and public can use the application. So for this, we will have different database, different set of API keys, different properties. Okay. Now we want this single application to run according to these different environments. Now, how we are going to manage this thing, that we are going to understand now. Now, what we want is that this bits payment provider is only made available when the profile is, when the active profile or the active environment is the production. Okay, so that we want. So here I used this profile annotation, and inside that mentioned the active profile name, that is the prod, or you can see the production, right? Now in this payment service, you will find that we are using this bits payment provider. We are requesting for this bits payment provider. Okay, now let me run this application and let's see what we get in the output. Okay, so we are getting some kind of error. Let's see. Right, so we are getting no such bean definition exception for this payment provider, because the profile that is currently active, let me go at the very beginning, and over here we will find the information of the active profile. Right, so you can see that no active profile set, falling back to default profile, and the profile that is active is the default. Okay, so now if the default profile is active, then the object of this bits payment provider is not present. right? Because we have restricted it to the production environment only, and that is what causing the error. Now, if we change the active profile to prod, then we can resolve this error. Now let's see how we can do that. So there is one property that is the spring profile dot active, spring profiles dot active, and then we can mention the active profiles name, right? So we can provide one value or we can provide the list of values. Right now we are going to go ahead with this one value, that is the prod. Now let me run this. You'll see that this time there is no error and everything is working as we expected. Okay. Now this is one way if we want to restrict some beans to a specific environment. So we can use this profile annotation. Now what if we want the application wide configuration, okay, for different environments? Now for that, what we are going to do is we are going to make the copy of this application or properties, right? Let me copy this and paste it. Now we are going to provide the new name, and new name is going to follow some convention, naming convention. Okay, so we will keep the application as it is, then we will put the hyphen and then the profile name, right? So we want, let's say, prod. So we are going to write the prod. So this is the profile name. Okay, now inside this we can configure our properties according to production. Let's say I want to reduce the logs that we are seeing inside the console. Okay, and one more thing that we can do is, let's say we want to turn off the banner. Now, what is banner? So you might have noticed that when we run the application, so there is a spring uh, banner is coming. Okay, so that we want to turn off. So this is how we can, there's one property and this is how we can turn that banner off, right? So we want that this configuration to run inside production mode. Okay, now let me run the application and let's see if this is working or not, right? So you can see that this time we are getting very less logs and rest the payment information. Okay, so everything is working fine as we expected. Now how this is working? So first, Spring Framework loads this application or properties file. So by default, it loads this default profile only. Then in this, it will find out that, okay, the active profile is prod. Then it will load this prod configuration. And the properties that are present inside this prod configuration are going to be used um, in our application, right? So this is how things work. Now we can create different configuration file according to environments. Now, what if we want to access these properties inside our class, inside our code programmatically? Okay, so what we can do is we can inject one class, and that is the environment class. Okay, let's inject that class. Now, we can use this environment object to get informations like the active profiles, default profiles, even we can get the property values, right? So we can utilize this environment object inside our code, right? So this returns the array, and this not we can print the active profiles. We need to convert this array into strings. Okay, right? So you can see the active profile is prod. So this is how we can utilize this environment object also if we want to use it somewhere in our code, right? So this is how we can manage different environments for our Spring Boot application. All right, in this section we are going to have quick overview on this Spring event system. Now, how to understand this Spring event system? You can think of like a railway station announcement booth. Now, how that works? So as soon as this announcement booth gets the information of train, the train that are arriving or departing from different platforms, right? So as soon as they get the information, they broadcast it, and through speakers we can listen to that information, right? And based on that information or based on that event, the passenger react. Now, if suppose you are at the platform and uh, you hear the information about the train that you want to catch, so then only you are going to react to that. Otherwise, you are going to simply ignore to that event or that information, right? So this is what happens. So like this, only this Spring event system works. Is received by this publisher. Okay, so this publisher is going to publish or broadcast this event. Then we have different listeners. Now this listener is going to only react if the event is of a type that this listener is listening to. So we can think of like suppose we have one user registered event in our application. So this is triggered when a new user is registered. Then we have the publisher, so you can think of application context only. So it is going to publish this event, right? And then we have one listener service, so it is listening to this user registered event. So as soon as this listener service get notifies or get to know about this event, it is going to handle this event and perform the task. So this is how this Spring event system works. And why we need this, because you see that now suppose if we want to send one mail, when the notification, now suppose in this application what we want a functionality, like we want to send one notification, right? When once the payment is done, we want to send one notification. Now how we can do this if we are not aware of this Spring event system? So what we will do, we will simply inject this service over here, this notification service over here, and we can simply here we are sending this event. So instead of sending this event, we will simply sending out the notification, okay, using this notification service. Now suppose some other functionality or the some other requirement comes that now not only notification should be sent, but an email and SMS also should be sent to user, okay, for this payment, for regarding this payment. Now again you will have two different services. Okay, so again you will inject those service over here, and then you will add the code to send the notification, SMS and email, right? So this is what we are going to do. Now this Spring event system allows, actually it decouples it. It allows us to decouple the services, and they will work without even knowing that they exist. And how they are going to work, because see this right now we have just understood that there going to be an event which is going to be published by event publisher, and we are going to have the listeners, and they are listening to particular event, and as soon as they will get that event, they will process that. Okay, so if we take this example of this notification service only, over here you can see that we have this notification event. So this is an event for sending out the notification. Okay, so we have simple class of notification event, right? And we have this application event publisher, and once the payment is done, we are publishing the event. We are creating this notification event, and we are publishing this event. Now for this we have the notification listener. So you see that this is a event listener. It is marked with this event listener annotation, and here it is receiving this notification event. And as soon as it receives this notification event, it is going to use this notification service and send out the notification. So basically what is happening over here, we are decoupling these services. So this payment service is not aware of this notification service. It is simply publishing the event, that is the notification event, and rest is handled by this notification listener, right? So this is how this Spring event system work. All right, now we know the theory behind dependency injection and application context and beans. So now we are going to build something real. We are going to build the headless file sharing app using the Spring framework core only. So We are going to build a system where a user can upload a file, encrypt that file before saving it, and also generate a secure access token, and the file will be automatically destroyed when the times runs out. So by the end of this project, we will have a complete understanding of the Spring Framework basics that we are learning throughout this series, right? So now first let us understand the architecture of this project, and then we are going to start implementing this. So first we have the presentation layer. So this is the entry point of our application, right? So inside this we have the terminal interface. This terminal interface is going to take the user input, which is going to pass that input to the service layer, right? So basically it is going to simply take the input and pass it to lower levels. That's it. It is not going to have any business logic, so it is not going to do any uh, logic related work, right? So this is the presentation layer. Next we have the service layer. Now the service layer contains upload service and download service. So we have two different services. Okay, now this upload service or this download service, they both work like a coordinator. They are not going to perform the tasks. They are not going to perform the task by themselves. They are going to pass the information or pass the input to lower level components and get the job done. So they are behaving just like a coordinator, right? So this is the service layer, and then we have this data access layer. So this data access layer is for saving and retrieving the file, right? So we are going to have two types of storage. First one is the in-memory repository. So we are not going to use any actual disk or any database to store the file. We are going to simply store the file in memory only. So this is one repository that we are going to use. Another one is the local disk repository. Local disk repository. In using this, we can actually save the file on our disk, right? So this is the data access layer. Then we have the security layer. Now before saving any file, we are going to encrypt our file, and we have two different encryption strategies. First one is the base 64 encryption. So this is a fast encryption, you can say, and other one is the highly secure encryption, that is the AES encryption, right? So before saving the file, we are going to encrypt that file, and for accessing the file we need the unique random access code. So we have one entity, we have one component, that is the access code generator, and that is going to generate this access code using which we can download the file, right? So this is the security layer, and on the right hand side we have the event layer. So this is regarding the Spring event system that we have gone through. Okay, so basically using this, what we are going to do is we are going to implement the file cleanup listener or the file cleanup system. That is file will be automatically deleted when the file is expired. So there is one service, that is the expired file scanner. So it will be running let's say every minute, or it can run every day or once in a week, like that. So it will scan all the expired file, and it is going to trigger one event, that is the file expired event, and then that event is going to be broadcasted by this application event listener, right? And as soon as this file cleanup listener is going to get that event, it is going to simply delete all those files, right? So this is how this whole project is working. So this is the architecture, and now let's start implementing this project, and then we will understand it in a better way, right? So let us start implementing it. Right, so we are going to start with the app config. So we are going to create one package config, and inside that we are going to create one class. Now we are going to mark this class with the configuration, because this is a configuration file, and we need the bean of scanner class. So why we are using this scanner class? Because we want to take the user input. So for that, we are going to need this scanner class. Now we are going to build the presentation layer. So again, we are going to create one package that is going to be presentation. Inside this package, we are going to create one class that is going to be terminal interface. Now we want this class to be managed by Spring Framework. So we are going to use the component annotation. Right, now we are going to inject the scanner bean that we have just created in the configuration file. Okay, let's create one constructor for this for auto wiring. Now we are going to have one method that is going to be start method. Basically, we can call this method to start the to start printing out the menu on the screen, and using that we can interact with our application. Okay, right, so we'll be running one while loop, and there will be four options. First will be for handling the upload, then we will have second option for handling the download, and third one to simulate the file expiration. So we are going to have these three options, and case number 4 will be to exit from this application. Right, now let's create these methods. Okay, so this is the display menu method. We have simply printed out the options, okay, and one prompt for taking the user's choice. Right, so we are going to implement these three methods after some time. First, let us create all these services, upload and download services. Then we are going to implement these methods. Now let's create one service package. Inside this, we are going to create one upload package. So this package is going to contain the upload service. So this upload service interface is going to have one method, that is the upload. It is going to take the file path that we want to upload and whether we want to use the fast encryption or not. So the user's choice. Okay, so this is the upload method and it is going to return the access code. Now let's create the implementation of this class. We have to mark this class with component because we want this class to be managed by this Spring Framework. Okay, so we are going to use this component. Okay, now we have to implement all the methods that are in this upload service interface. Okay, now first we are going to generate the unique access code. So let's create one variable code and we are going to use the code generator service which we have not created yet. So we are going to create it. Right, so let's do one thing. Let's add the dependency of this code generator and let's create one package access code, and inside this, okay, so we have to rename this package first. We want this to be outside of this upload folder. Right, now we need to create one code generator package. Right, now we need to create the interface of this code generator. Let's add this method to this interface and this is going to return the string, that is the access code. Next, we are going to set the encryption strategy. So again, we need to create one variable for that. So we are going to use this use fast encryption to decide the strategy. Okay, so we will have two types of encryption. First is the base 64 encryption and another one is the AES encryption. Now let's also add the dependencies of these encryption strategies over here. Okay, let's create one package and we are going to name it as the security because this is related to security layer. Now we are going to create this encryption strategy interface. So let's create this class inside this security package. Okay, and we are going to change it to interface. Right. Next, we are going to get the raw content of the file, right? So we'll be using this files utility, okay? And we'll be reading this file as the string, not as the bytes. We'll be reading as the string. Simply, we will provide the file path over here, okay? Or we can do one thing, we can use this path of, and then we can pass this file path, right? Next, we are going to encrypt the data. So we need one variable, and we are going to use this encryption strategy to encrypt the file. Okay, let's create this method inside this encryption strategy, and this is going to return the string only. Now we have the encrypted data also. Next, we are going to save it, and for that we are going to need the file repository. Right, so let's create the file repository. So we will have one variable as the file repository, and this repository is going to have one store method, and we are going to pass the code as well as this encrypted data. Now let's create this file repo. Now this is related to data access layer, so we need one package that is going to be repo, and inside this we are going to create the interface of this file repo. So let's create the interface of this. Now also add this method, and this is not going to return anything. It is just going to save the file. That's it. Now after saving the file, we are going to simply return the access code. Right. So this is the logic of this upload method. Now this read string can throw this IO exception, so we need to handle this. So we are going to wrap this code with the try catch block. So in case of error, we are simply going to log that error, and we are going to return null. That's it. Now let's create the constructor for this service so that these dependencies can be auto-wired by the Spring framework. Okay, now this upload service is almost done. Now let's create the download service. So we need to create one more package inside this service package. So let's name it as download, and we are going to need one interface, and that is going to be download service. Okay, so this download method needs parameters. First is the access code for finding out the file. Okay, then we will have the destination path where we want to save the downloaded file, and we need to also tell that whether this file was encrypted by fast encryption or not. Okay, so this is the download method. Now let's create the implementation of this interface. Again, we need to mark this with the component annotation because we want Spring Framework to handle it, right? Now let's implement this download method. Okay, so first we need to get the encrypted content of the file. So for that, we are going to need the file repo. So we are going to have this retrieve method, and we are going to simply pass this access code, and in return, we will get the encrypted data. Right, now let's add this dependency. Okay, and we need to add this retrieve method, and this is going to return the string only. Right, so this is the retrieve method. Okay, after getting this encrypted data, we are going to check whether this encrypted data is there or not, whether it is empty or not. So we are going to check for that. Okay, so in case if this encrypted data is empty, we can say that this uh, the file that we are searching for is not present, and we can simply log that message in the console. Now if the data is there, then we need to figure out the encryption strategy based on this variable, that whether we have opted for fast encryption or not. So again, we need both of the encryption strategies. So we are going to copy it from this upload service and paste it over here. So if it is fast encryption, then we are going to use this base 64, otherwise AES. Now we are going to decrypt the data, or we can simply name it as data only. We are going to use this encryption strategy and we are going to decrypt the data. We will pass the encrypted data over here and in return we will get the decrypted data. Right, so let's create this method also, and this is going to return the string. Then we are going to simply write that file to destination path that we have received in this method. Okay, so we are going to use that and we are going to simply write that file. Okay, and simply if this whole thing is successful, then we are going to return true, otherwise we are going to return false. Okay, so this is the download method. Now let's create one constructor for this. Right, so this download service is also almost done. Now let's implement this code generator class. Again, let's mark it with at component annotation. This is going to have this generate method. So let's implement this method. We are going to generate the random access code. So this code will be of 6 digits. Okay, 6 characters. Now let's see how we are going to generate this code. Okay, so we have created one string of the characters that are allowed for this access code and one constant variable for this code length. Right, so we are going to use this secure random class and we are going to randomly select any one of the character and we are going to append it to this string builder object and finally we are going to return that. Okay, so this is how we are generating this code. Now we need this dependency of secure random, so let's create one variable for that. Okay, and for providing this dependency we need to create the object of that. Right, now we are going to open this app config and over here we are going to create this secure random and we have to mark this method with @bean and we are going to simply return new object of this secure random. Now let's create one constructor for this dependency. Okay, so this code generator class is done. Now let's get back to our terminal interface and let's implement this handle upload and handle download method. Right, so this is the handle download and handle upload method. Okay, so we are simply taking the inside this handle upload, we are simply taking the path of the file that we want to upload and whether we want the fast encryption or the secure encryption, that is dependent on the choice of the user. So that we are taking from the user and then we are simply uploading that file. Okay, and in return we will get the access code and we will print out that access code. And in this handle download we are taking the code and the destination where we want to save the downloaded file, right? And also we need this fast encryption, so that also we are taking from the user and we are passing all these to this download method. And if the access code is correct and path is correct, then that file will be downloaded to that path, right? Now, I've created two helper methods also. So these are prompt and the prompt boolean. So this prompt is very simple method. It is going to simply take the input using this scanner and it is going to return that. That's it. And this prompt boolean is going to check whether this prompt the input that we receive from this prompt is equal to y or not. Basically we are checking, we are using it for this fast encryption. We have two choices, right? So yes or no. So we are simply checking whether user entered y or n. So if if user entered y, then that means we will get true, otherwise false. Okay, now let's add these two dependencies, load service and download service. Now let's create another constructor. We are going to simply replace this constructor. We are not going to need this constructor, so we can simply remove this. Right, so this is the terminal interface. Okay, now let's do one thing. Let's run this application. Right now, I'm going to create one file over here for testing. So this is going to be test file dot txt. This is a test file for Headless File Sharing App. Okay, let's save it, and now let's run this application and hope it runs fine. Okay, we got one exception, that is for this encryption strategy. Okay, so let's see what is the exception. Let's run it in debug mode. Okay, we have not created the bean of this encryption strategy. So let's create the implementation of this encryption strategy also. So first we are going to create base 64 encryption, and this is going to implement this encryption strategy. For encrypting, we are going to simply use this base 64 encoder, and we are going to encode this string. That's it. And similarly, we are going to use base 64 decoder for decrypting the file. Right, so this is the base 64 encryption strategy. Now let's create the AES. Again, we are going to mark this with component. So for now, we are not going to implement this AES. We are going to simply return the data that we are getting. We are going to implement it later on. Right, so now we have the encryption strategy. Let's run this application now. Okay, now this file repo is missing. File repo implementation. So let's create implementation for this also. Right, so let me rename it to in-memory file repo, because we are going to have two type of repository. One is in memory and another one is the local disk. Okay, and this is going to implement file repo. Let's mark it with component. Right, so for this we are going to simply use one hash map to save the data, and that's it. Okay, so this is the in-memory file repo. Now let's create one local disk file repo. But before creating the local disk, let us first get rid of this error. So we are going to return the optional of a string, okay, not just the string. So let's change it over here, right? And over here we need to change our code. So instead of this encryption data, we are going to use this get method to get the actual object, because over here we are getting the optional, right? So this is how we can access the actual value. Now the error is gone. Okay, great. Now let's create one more class, local disk file repo. This is going to implement this file repo. Let's again mark this with component. So for storing the file, we need one folder where we can store all the files. So that is going to be the secure storage folder, right? Now this storage directory, now if this storage directory is not present, then we are going to simply create that directory. So we are doing this right after creating the object of this local disk file repo. That's why we are using this post construct. Okay, so that is going to be run just after the object is created. Okay, so this is how we are going to simply save the file. So we are going to have the destination path, and we are going to simply use this files utility to write the files data. That's it. Okay, so we are going to simply save the file like this. Again, retrieving is also simple. First, we are going to check whether this file exists or not. And if it exists, then simply we are going to read that file. We are going to read it as a string, and we are going to return that file. Otherwise, we are going to return the optional, empty optional. Okay. So that is how we are going to retrieve the file in case of this local disk file repo. Right. So we are done with this file repo implementation also. Now let's run this application. Okay, again we are getting the error, and okay, now we have to So we need to specify about this file repo that which component we want to use, which object we want to use as the primary. Okay, so over here we are going to resolve this ambiguity, right? So let's use this primary annotation. So by default we are going to use this in-memory file repo. Okay, so we are going to mark this with it primary. Now let's run this again. Okay, so okay, so this time we are not getting any exception. Right now we need to use this terminal interface, and how we are going to use it. So we need the context. Okay, so let's have the reference to that. Then we are going to need the bean of this terminal interface. So this is how we are going to get the bean and save it in one variable, and we are going to call the start method. So this time we should be presented with this the menu that we have designed. Okay, let's run this application. Right, so now we are getting this menu and the choice. Okay, let's start with upload. Now the file name is testfile.txt. We want fast encryption. Okay, great. So our file is stored in the hash map, and let's check that. Okay, so for checking, simply what we can do is we can go to this in-memory file repo, and we can create one breakpoint over here, right? Okay, we need to run this application in debug mode first, right? Again, we are going to upload the file. So the file name is testfile.txt. Okay, now let's check this virtual storage. So you can see that the size is 1 and the file data is stored. Okay, so this is how this in-memory file repo is being used. And let's resume this. Let's try to download this file. So we are going to provide the access code and the destination path. So let's name it as recovered.txt only. Yes, we used the fast encryption. Okay, let's check whether we got any file over here or not. So let me just reload it once. Okay, yes, you can see that we got this recovered file, recovered.txt. So this is how you can see that both the upload and download functionality is working with this in-memory file repo. Now let's do one thing. Let's change it to local disk, and for that what we are going to do is we're not going to simply mark this with primary. We are going to use the profile. Okay, so we want that if the profile is development, then this bean should be active, this component should be active. Okay, and if the profile mode is prod, then we want this local disk, right? And in order to use this in in order to use this profile, we need to specify it over here. So we are going to use the property, and that is spring dot profiles dot active, and we are going to give the name as prod, not dev. Let's run this. Right, so let's try to upload one file, test file dot txt. Okay, so file uploaded successfully. Now let's check. Let me reload it. Okay, so you can see that we have the file over here inside this secure storage folder. Now let's try to download this file. Okay, let's check for this recovered -2 file. Again, we got this file over here, and you can see that this the file that we have uploaded, we have got the same file only. This encryption and decryption is also working fine, right? So you can see that both of the in-memory or this local disk repo, local file repo, so both are working perfectly fine. So our upload and download services are working perfectly fine. Okay, now we need to create this event thing. Okay, event layer. So let's start implementing this thing. Let's create one event package, and inside this we are going to create one event, that is file expired event. Okay, and we are going to have two properties. We are going to need two properties, and that are the access code and the file. Okay, so we can make this as a record, or we can uh, have just a file path only. We don't need this access code. Okay, so let's create this file path only, right? Now this is the event, and for this event we need to create one listener. So let's create one package listener. Inside this we are going to create file cleanup listener. We are going to mark this with component. Okay, and we are going to create one method that is going to handle this file expiration event. Okay, right, so we are going to use this file repo, and we are going to create this method that is wipe from storage. Okay, so let's first add this dependency, that is the file repo. Okay, let's create one constructor. Great, now let's create this method, and this is not going to return anything. One more thing that we need to do inside this listener, we have to mark this with event listener. Okay, okay, so we have created the event and the listener for that event. Now we want the publisher. Okay, so for that we need one service, and that is going to be file cleanup service. So let's create that service. Basically this is the scheduler, but right now we have not understood about the scheduling and concept related to that, so we are going to just simulate this thing. We are not going to use the actual scheduling thing. Okay, so let's create one class, that is the file cleanup service, or the file cleanup scheduler. Okay, and we are going to move this in some other package. Let's create the scheduler package, and let's move this over here, right? We are going to mark this with component, and we are going to need one method, and that method is going to be simulate time expiration, right? So we are going to need two things, not just this file path. We are going to need this code also, access code also. So that will be lot more easier to uh, simulating this scheduling thing. Okay, so we are going to need these two things, right? So now we want to publish this event. Okay, and we need more information regarding the file. So we need the time of creation, or the time when the file was uploaded, right? And then only we can calculate whether the file is expired or not. So we need a few more information, and now we are going to do one thing. Now let's create one model package, and inside this we are going to create the file metadata. Okay, so we need the access code of this file, then we are going to need the file expiration time in second. Okay, and also we are going to need the time of creation, right? So we need created time field. Now let's create one constant file expiration time in second. So by default it is going to be 60, right? And let's create one helper method inside this only, and that is going to be is file expired. So we are going to check whether the current time, right? So we are going to simply return this value. Now we need to change this file repo also a little bit. Okay, let's do that. So while storing, we need three things. Okay, so code, encrypted data, and the file expiration time, right? And while wiping out from storage, let's simply take this file metadata as the input. Okay, let's fix the problems. So we are going to add this one extra parameter over here, right? And we need to implement this wipe from storage method also. Now we are not going to use this access code as the key. We are going to use this file metadata as the key. Okay, so let's create one method, new file metadata. Okay, we are going to pass this code, encrypted data, and file expiration time. So by default, uh, it is the 60 seconds. So that we are going to pass when we are calling this method. Okay, right. So here we don't have to pass this encrypted data. We have to pass the time, and over here we need to pass the current time, and here we have to pass the data. So this is done, and now we need the file metadata and the access code. And rest we can mark as null. This is the int, we can use -1. For this we can mark as null, right? Now let's implement this wipe from storage. Now we are going to simply remove the key from this hash map. Okay, because it is a hash map, so we don't have to delete anything. We are going to simply remove that key, right? So this is how this in-memory file repo will be implemented. And now let's make changes inside this local disk repo. We would have done this thing in a better way using the refactoring, but this is a small change, so that's okay for now. Now we need this information, right? So we are going to save this information uh, in file name only. Okay, let's use file name only for to keep the thing simple, right? So first we are going to store the expiration time in second, and then we are going to save the file created time, because we need both the things. Let's make this as a formatted string, so that will be better, right? So for retrieving the file, we are going to change the logic. Now instead of directly accessing the file, what we are doing is we are searching the file uh, inside the storage directory with this access code, and then we are getting that file. Okay, so that is how we are doing the thing. And now we have to implement this wipe from storage. So let's implement this. Let's do one thing. Let's extract this as one method. So we can also use this inside this wipe from storage. Okay, so let's do one thing. Let's extract this method, and let's name it as get file. So instead of directly returning the content, what we are going to do is we are going to return the file only. Okay, so we are going to return the file over here. Okay, and over here we are going to change it to optional of path, because this is the path, not the actual file. And over here again we need to make some changes. So this is the, so this is going to be path. Okay, and if path is present, we are going to retrieve that file, right? So this is done, and over here we are going to remove this file, right? Right, so we are going to simply delete the file if it exists. Okay, and we will simply log out the messages. Now let's run this application and check whether this is working or not. Okay, over here we need to pass the default file expiration time, so it's use the constant that we have created. Okay, let me run the application. Right, first we need to upload the file, so that is going to be test file dot txt. Okay, we got the access code, and let's see how it is stored. So you can see that this is how it is stored in the local disk. Now we will paste the, now first we need to select the option, then we need to paste the access code, and let's give the name as rec.txt. Okay, let me reload it once. Right, so we got the file over here, so it's working, right? So upload and download is working. Now let's simulate this file cleanup scheduler. Okay, now we want to publish this event, so for that we need the event publisher. So let's get that. Let's create one constructor. Okay, we need publisher, not listener. Event publisher. Let's rename it event publisher, and let's create another constructor. Right, so this is done, and we are going to pass this file path. Okay, let's do one thing. Let's add the code over here, access code, because that we need. Okay, so we are going to pass both the information with this event. Now let's go to this listener, and we are going to call this method, and over here we need to pass the metadata. So let's pass that. So we are going to pass the code. Okay, let's add this to this simulation to this terminal interface. So now we are going to implement this method. Okay, and for that we need this scheduler. So let's add that over here. Right, so let's add it into this constructor also. Okay, not, we are not going to create the object. We need this to be injected. Okay, and then we are going to simply simulate this. We are going to use this method. Okay, let me make it public. So let's simulate this expiration, and we are going to do this for this file. Okay, so we are not writing any logic for passing this. Okay, for this for now. And if you want, you can implement that, so that will be a better approach. So that scheduler is going to simply scan for all the files, and it is going to pass this information, and it is going to figure out that what all files are expired, and it is going to simply delete that, right? Okay, so we can remove this file path. I guess we don't need that. Okay, let's make changes over here. Right, so this is done. Now let's run this simulation. Okay, so now we are going to simulate expiration. Okay, so hard disk wipe successful for this file, and let me reload this. Okay, you can see that file is gone. So this scheduler is also working, right? So we have implemented almost everything except this actual implementation of this file scheduling, so that we can implement later on when we will discuss about the scheduling and all, so that we can discuss then. Right now we can leave this thing as it is. Okay, and also this security, we have not implemented this AES encryption. So for this we need the external library. So if you want, then you can simply add the external library, and you can uh, use that library over here, and make changes inside this class, and you can uh, experiment the things whether it is working or not. So you can do that, right? So we have almost covered all the concept that we have gone through. We have covered the concept of context, component classes, okay, ambiguity, profiles, right? So we have almost covered every topic that we have gone. So so this project was for this only, for revising all the concept, right? All right, we have spent a lot of time at how Spring works in a very practical and hands-on way. But before we wrap up this tutorial, I want to take a step back and officially introduce the Spring framework, its key features, and its architecture. At its most basic level, the Spring framework is an open source, lightweight application framework for Java platform. What does actually this mean? It means that Spring handles the complex behind the scene infrastructure of your application, so that you, the developer, can focus entirely on writing your business logic. It was designed specifically to simplify Java enterprise development, making your code easier to test, easier to maintain, and completely decoupled. There are a few core features that make Spring the industry standard. First is the inversion of control, that is IoC, and then the dependency injection. This is the absolute foundation of Spring. Instead of your objects creating their own dependencies, the Spring container, the Spring IoC container, injects those dependencies for you at the runtime. Next is the expect oriented programming, or in short AOP. This is a fancy way of saying that Spring lets you separate the background task like security, logging, or transaction from your main business logic. Spring also excels at data access. It provides templates that eliminate all the repetitive, error-prone database boilerplate code, and it integrates perfectly with ORM tools like Hibernate. Then it gives us the Spring MVC framework, which is for building the robust web applications and the REST APIs. And recently, it has brought that exact same philosophy to AI, that is artificial intelligence, allowing developers to integrate LLM, large language model, just as easily as they would a database. Now let's look at how all of this is actually put together. Now let's look at how all of this is actually put together. Spring is highly modular. It contains about 20 modules, which means you only have to bring in parts of the framework that you actually need. Right at the bottom, we have the core container. This is the heart of Spring. It contains the beans core module that provides that dependency injection feature that we just talked about. Moving up, we have the AOP and the instrumentation layer, which handles our cross-cutting concerns like logging and security. Then we have the data access and integration layer. This is where the JDBC abstractions or ORM integrations and transaction management live. It entirely simplifies how your application talks to a database, right? Next is the web layer, which houses the Spring Web and Web MVC. This provides everything you need to build a user interfaces, handle web requests, and create RESTful services. And alongside all of this is the test module, ensuring that you can write unit and integration test for every single component of your application. Finally, I have to highlight the newest and the most exciting addition to this ecosystem, that is the Spring AI. Spring AI takes the core design principle of Spring, like portability and modularity, and applies them directly to AI engineering. It solves the biggest challenge in the modern development, connecting your enterprise data and APIs to AI models. So this is the beauty of Spring AI. You can write your code once and easily swap between AI providers like OpenAI, Anthropic, or even local models via Ulama without having to rewrite your entire application. It provides a Java-friendly way to handle prompt templating and interacting with vector databases and implement advanced patterns like RAG, retrieval augmented generation. It takes the AI integration and turns it into clean standard Java code. Alright, so that is the end of this series. I hope you enjoyed it. Don't forget to share with your friends. Also, do like this video to help the algorithm and comment for the topics that you want. So do comment that also. So I'm going to answer your doubts in the comments only, and if uh, it requires any video, so I'm going to make that also. Thanks for watching. I'll see you in my next video.